So we're on page 47, number 6, and it says you have a rectangular box. So, oh my gosh, I'm not a good drawer. So here's the rectangular box. Hopefully yours looks better than mine. And here's your length, width, and height. And it says that each of these length, width, and heights are consecutive integers with the largest dimension k. So I'm not sure if length, width, or height is the largest dimension, but luckily with our volume of a rectangle shaped box, you have volume equals length times width times height. So it doesn't matter which one comes first because they're all multiplications. So let's pretend that the length was the biggest. So we would make this k. And this means that since they're consecutive integers, this would be k minus 1 and k minus 2. So our volume would equal k times k minus 1 times k minus 2. And if they were even or odd, this would be k minus 2, k minus 4. But since it was just consecutive integers, this is our answer right here for the volume of this rectangular box. Example number 5. We're on page 47. And we're going to look at number 8. It says a bus traveled for 2 hours at a rate of r, miles per hour, then decreased the speed by 10 miles per hour and traveled for 1 more hour. How far did the bus go? Well, you're going to use distance equals rate times time. So, okay, I made a mistake, so I'm restarting this, so it looks a little funny on your video. But distance equals rate times time. So, let's plug in what we know. We're using this equation, first of all, because anytime we're talking about rate and distance and time, you always have distance equals rate times time. D is your distance, R equals your rate, and T equals your time. So we want to know how far the bus went. So we don't know. So that's going to stay D. We know that we traveled for 2 hours, so that's our time, T, at a rate of R miles per hour. So we're just going to have 2 times R. And then it says we decreased our speed. So we were going R and we decreased our speed by 10 miles per hour and traveled for 1 more hour. So here's our new rate at 10 miles per hour less, and our new, for another hour, which is our time. So we're going to simplify this expression so we can answer the question, how far did the bus go? So if this wasn't a 1, we would distribute it to both parts, and we'd have 2r plus r minus 10, which is 3r minus 10, and that is our distance. That is how far the bus traveled. Okay, let's do one more, or actually we're going to do 2 more. Example number 6. And this is same page, but we are doing number 10. Number 10 says an angle has a measurement of x degrees. So let's make an angle and it's x degrees. Find the average of the measures of a complement and supplement of the angle. So if you remember, a complement angle from geometry is 90 degrees, and a supplement is 180 degrees. So if we look at, this would be 90 and the whole thing would be 180. It says find the average of the measures of the complement and supplement angle. So we know if we're looking at the angle, we're going to have 90 minus that x, that degree for that angle, okay, because it's complement. And then we'll have 180 minus x for the whole 180, taking out this this degree. So to find the average of what the complement and the supplement are, you have to add them together and divide by 2 because there's this complement and supplement, so that's 2 different types of angles. And we would simplify this and get 270 minus 2x divided by 2. 2 will go into both of those, so it'll be 135 minus x, and that is what we're looking for to answer the question, what is the average of the measurements of the angles? And so we took what the measurement of this one was and the measurement of this one was, and we added them together and divided by 2 to find the average. Example number 7. We're going to look at the same page, number 12. This is the last one. It says for these particular problems, you got to use volume equals 1/3 base times height, where B is the area of the base. Okay, so volume, let me read the problem first before I begin. Number 12, the pyramid has a rectangular base. Find the volume if the length and width of the base and height are 3 consecutive odd integers and x is the largest integer. So let's draw this. Again, I'm not a good drawer. It's a rectangular base. Let's see. So this is my length, width, and then my height is going to be right here for my pyramid. And it says that the length, width, and base and height are 3 consecutive, the length and width of the base, okay, and that makes sense. The length and the width of the base and the height are 3 consecutive odd integers, and it says x is the largest integer. So we're going to have x, again, it doesn't matter if it's length, width, or height, x for the biggest one, x minus 2 because these are odd, and then x minus 4 for the height. So we would plug that in. The area of the base would be length times width, so you can also think of this volume as 1/3 length times width times height. So we would plug those in as 1/3. My length is x, my height is my width is x minus 2, and my height is x minus 4. And you don't have to simplify it. You can leave the answer like this, and that is the pyramid, the volume. That is the volume of the pyramid. Okay, then that's it.